So we're going to take the melting point now of the acetylsalicylic acid that we isolated, and we're also going to take the melting point of pure acetylsalicylic acid that we bought from a chemical company. And so what we're going to do is we're going to use this open-ended capillary tube. It's called a capillary tube, like your capillaries with blood. It's open-ended here to collect solid, and then it's closed here for the actual melting process. And so what we're going to do is we're going to get a little bit of solid and then observe the phase change from solid to liquid, and that melting point is very important. If it's the same, then we can use that as a piece of data to confirm that the isolated material is indeed acetylsalicylic acid. A common issue to keep in mind here, because the literature melting point being 134 to 136, is that the ASA can actually hydrolyze in the capillary tube. And what that means is that the ester of acetylsalicylic acid, as it melts, the ester undergoes hydrolysis to give you back the carboxylic acid from which the ester is derived. This is called acetic acid. And then the other part being the phenol. So that would be salicylic acid. So when you hydrolyze this ester, you get the phenol and the carboxylic acid back. What I want to emphasize here is, here's salicylic acid, by the way, and here's what's called an acetyl group. This is an acetyl group where you've got a carbonyl and then the methyl bonded to the carbonyl carbon. This is the acetyl group, and then whatever it's bonded to, you can then say what it might be. This is a hydrocarbon chain, so necessarily that's an ester of acetic acid. All right. So in terms of collecting solid, what you're going to do is that you just need a little bit. You just very lightly pat down on the solids you've collected after you've taken the weight of the thing, and you just gently tap on the lab bench to try and have the solid go down into the tube. But you'll see that sometimes that doesn't work so well. So we've got a couple different ways to go about doing or helping us do that, especially when you've got a solid that's greasy. For example, cholesterol tends to stick, and we'll see that in the other experiment. But this is called a tube tapper, and it literally just taps the tube and vibrates the tube. You can see like that. And it's doing the work for us, and now we've got just a perfect amount of solid at the bottom closed end part of the capillary tube. And so then we're going to put it into the the melting plate, and then this is these are the two melting point capillary tubes. So the one on the left is
this is our sample.
Is the isolated sample, and the one on the very far right now over here is pure acetylsalicylic acid from the company. And so we're going to watch both melting points at the same time to try and see and get that melting point range. So Dominic is going to take over and also describe how to use the Digimelt, the melting point apparatus and so on.
Okay. So first, to turn it on, you do this switch back here. And then you can set the start temp, your ramp rate, and where it stops at. This doesn't go past, I believe 260 is the max. Yeah, so it won't go past 260, and we won't need it to because the literature melting point of ASA is 134 to 136, which was reported by Sigma Aldrich online. So I will have, right now it's at room temperature, but you can have it speed up to a specific temperature and then slow down at the ramp rate you'd like it. So we'll have the ramp rate be 5 degrees a minute, and we'll have it slow down to there when we reach, we can do it at maybe 125 would be good, even 120. So when I click start, it's going to preheat and it's going to climb fast, and then when it gets to that start temp, it'll stop, and I have to click start again in order to go at the specified ramp rate. So as it's going, we'll keep an eye on it, and I'll only be able to capture just the solid inside the chamber here and not the numbers, so I will just report the numbers as it's changing. But what you want to report is the first sign of liquid as the start temperature, and as soon as it's all become liquid as the stop temp, because remember it happens over a range, not at one given spot. But the more pure it is, the narrower that range will be. So a really impure sample will happen over a broader range and often will be depressed relative to the literature melting point. But we didn't do any kind of recrystallization or purification method of our sample, so you might see it not be as close to the 98% pure sample we have, but we will see. And also, if this hydrolysis does undergo inside this melting point apparatus, it will change the melting point, because salicylic acid has a higher melting point of, I believe, 158 degrees Celsius. So if that did happen, it may skew that melting point. So we're at 112. It's still climbing, but it's slowing down because it's approaching that start temp we reported. So I'm going to write on here. It's from TCI. Sigma Aldrich was where I got that literature melting point from, but the sample that made the batch is TCI. So it's just about at 120, so it's going to let me click start again. It says melt. And now it's going to go at that ramp rate we set at 5. You can do it at 2, 5, 10, and 20. The slower it goes, the more accurate your reading can be then. So again, on the left is our sample from the aspirin tablet, and on the right is the sample from TCI that we got out of the bottle. At 123. .127, still no signs of melting. So as soon as we see a droplet in either of them, we'll have that we'll record the temperature and have that be the start time. It's at 1:30 now. I'm gonna have the start temp for the one on the right be now at 131. Looks like ours is shrinking, but I don't see any droplets yet. Okay, so I'm gonna have now be the start time for our sample. And knock it down. Sometimes an air bubble just collects, but it doesn't. Okay, it looks like they're both all gone at 136. So the TCI sample actually happened over a little bit broader of a range. I think that's just an air bubble on the right one. But they're both liquid. So it's going to keep on climbing. But since they're both melted, I'm going to stop it. And here I have recorded those two melted points. The units.